Welcome back, Math Masters! A new scroll has arrived at the dojo gates. Today, you will be training in place value from the thousandths to the millions to earn your next badge. For the number 6,075,813 and 245 thousandths, show this number in standard and expanded form. How many place values apart are the millions and the thousandths? How are the place values to the left and right side of the decimal point connected? Study well. The path to mastery begins now.
Welcome back. It's Jenna again. I have a feeling we'll need to use everything we've learned about place value patterns, number forms, and how digits change in value across different places to conquer today's challenge. Are you ready to connect the millions to the thousandths and prove your mastery? Have your guided notes ready. Training starts now. We already know how to represent whole numbers through the millions and decimals down to the thousandths in standard, word, and expanded forms. Now we're going to put it all together and work with numbers that include all of those place values in a single number. For 3,071,952 and 453 thousandths, show the number in both standard and expanded forms. Pause the video here to record your thinking in your guided notes. How did you do? The standard form of this number has a 3 in both the millions and the thousandths places, and the expanded form is 3 million plus 70,000 plus 1,000 plus 900 plus 50 plus 2 plus 4/10ths, plus 5/100ths, plus 3/1000ths. Remember, we don't record plus 0 if there is a 0 in a place value, because adding 0 doesn't add any value. Let's try another number. This time, convert the standard form of the number into word and expanded forms. Pause here to record your thinking. The commas and decimal in the number remind us where to say our labels. So this number is 6,237,412 and 2 thousandths. The word "and" is only used once because it shows us where the decimal point is. In expanded form, we have the value of each digit added together. Since the last 2 is in the thousandths place, we make sure to use placeholder zeros to note the correct place value of the digit. Nice work, Math Masters! The second part of our challenge today asks, how many place values apart are the millions and thousandths places? But why is that helpful to know? There must be a connection between how far apart place values are and how their value changes. We know that each time we move one place to the left on the place value chart, the value becomes 10 times greater. And if we move to the right, the value becomes 10 times smaller. Let's look at a couple of examples. From the hundreds place to the tens place is one place value apart, or one place value jump. And the value becomes 10 times smaller. One jump, 1, 0. What about from the tenths place to the thousands place? That's 4 places apart, and the value becomes 10,000 times greater. That's 4 jumps, 4 zeros. Excellent work! What's that, Mia? Oh, Mia's got a training tip for us. When we count place value jumps, we can match them to the number of zeros in the number we multiply or divide by. 1 jump, 1 zero. 4 jumps, 4 zeros. That pattern comes from something called powers of 10, numbers formed by multiplying 10 by itself. Each time we multiply by 10, we add another zero. For example, 100 is 10 times 10. 2 jumps, 2 zeros. 1,000 is 10 times 10 times 10. 3 jumps, 3 zeros. Powers of 10 are always made up of the digit 1 followed by a certain number of zeros. Knowing this pattern helps us compare place values across both whole numbers and decimals. Use the training tip to compare these place value positions. 10,000ths place and hundredths place, thousandths place and hundredths place. How many place value jumps are there between each pair? Then, what power of 10 would you use to describe the relationship between their values? Pause here to record your thinking. Let's check your thinking. Between the 10,000ths place and the hundredths place, there are 6 place value jumps. That means their values are related by a power of 10 with 6 zeros, 1 million. So the value of the hundredths place is 1 million times smaller than the value of the 10,000ths place. Now, between the thousandths place and the hundredths place, there are 5 place value jumps. That matches a power of 10 with 5 zeros, 100,000. So the value of the hundredths place is 100,000 times greater than the value of the thousandths place. Matching the number of jumps to the number of zeros in a power of 10 helps us compare place values clearly, no matter where they are on the chart. Whole numbers, like thousands or millions, help us represent very large values. Decimal place values let us describe small, fractional parts of a whole. But even though the size changes, the pattern stays the same. So, how are whole numbers and decimals connected? They're part of the same base 10 system. Each place is 10 times greater to the left and 10 times smaller to the right. Where have you seen both whole numbers and decimals used together in real life? I instantly thought of money, with dollars represented as whole numbers and cents represented as decimals. Your challenge still awaits. Complete it, and the combined place value badge is yours. Consider the number 6,075,813 and 245 thousandths. Show this number in standard and expanded form. How many place values apart are the millions and the thousandths? How are the place values to the left and right side of the decimal point connected? Pause here to use everything you've learned to complete the challenge. In standard form, there is a 6 in the millions place, a 0 in the hundred thousands place, and the decimal is placed between the 3 in the ones place and the 2 in the tenths place. In expanded form, the number is written as 6 million plus 70,000 plus 5,000 plus 800 plus 10 plus 3 plus 2 tenths plus 4 hundredths plus 5 thousandths. There are 9 place value positions between the millions place and the thousandths place. That means we would need to multiply 10 times itself 9 times, making the millions place 1 billion times greater than the thousandths place. Whole number and decimal place values are connected because they follow the same base 10 pattern. But the values of whole numbers are much larger than the values of decimal numbers. For example, the digit 5 appears on both sides of the decimal. On the whole number side, it holds a much greater value, while on the decimal side, it represents a very small fraction of a whole. Awesome work, Math Masters! You solved another Math Mastery Dojo challenge. So, what have we learned today? We learned that whole number and decimal place values are connected because they all follow the same base 10 system. And we know that numbers from the millions place to the thousandths place can be represented in standard, word, and expanded forms. You've earned the whole number place value badge, but your training isn't over just yet. Be sure to complete the practice questions and extension activities that go with this lesson to practice working with place value. And remember, Math Masters, in math, as in training, progress comes with patience and practice. I'll see you next time.
Hey, hey.